Okay, so let's we start with this discrete random variable. First of all, we will try to understand what is a discrete random variable. Okay, so discrete random variable. I think you are very well known with the discrete word. This word we discuss a lot in stat discrete value and continuous value, or discrete data or continuous data. Discrete means a fixed value, right? So let's we look for event. Suppose you toss a coin, right? Tossing a coin. So tossing a coin, what are the outcomes? Head and tail. Okay. So let's we consider x is a random variable, discrete random variable. Okay, x is a discrete random variable, and what it stand for here? Getting a head, getting a head in tossing a coin. Okay, so x is a random variable and it stands for getting a head, right, in this tossing a coin. So then we will make a probability distribution table here, and we will look for the all possibilities. So this is the x is what? Getting a head. And when a coin is tossed, so there are two possibilities. You can get head and you cannot. So if you can not get head means 0. Okay, if you can get head, that means 1, right? You'll get only one head. So two possibility, you can get head but only one, since there is only one tossed, and there is another possibility that you cannot get head. So if you look at here, so if you look for the probability of not getting head, or not getting head is denoted by random variable x equals to 0. Okay, so this will be 1 over 2, or even if a probability of getting head also 1 over 2, right? So this is now, I think you would have understood discrete random variable and how to find out the probability of this um, discrete random variable. Okay. Yeah, I would like to tell you here one very important thing. Suppose sometimes we have a question, we have a probability distribution table, and there we need to check whether that is correct table, or that's how the probability distribution of a discrete random variable. So in this case, we need to check the probability. If you add all the probabilities, sum of the probabilities should be equals to 1. Right? It means if you look at this column, or this row, 1 over 2 plus 1 over 2, that is equals to 1. Sum of probabilities should be equals to 1. Right? Let's we consider one more event. Suppose there is a random experiment, means a dice thrown, right? Dice is thrown. So what are the possible outcomes? 1, 2, 3, 4, 5, 6. Okay, these are the possible. Suppose x is a random variable getting a prime number, getting a prime number, right? Getting a prime number. So getting a prime number is a discrete random variable x. So we'll make a probability distribution table. So this is a x random variable and it's a probability of x. Okay, so getting a prime number, so we make that prime number, or we may not, right? So two possibilities, we can get and we cannot. So if we cannot get, means 0, random x variable will be 0. And yes, now then here getting a prime number, it will be 1 for this. So if we look at here, how many prime number we have? We have 2, 3, and 5. Okay. So we have 3 prime number, and then obviously then there will be 3 non-prime number, 1, 4, and 6. So getting not a prime number, its probability will be 3 over 6. 3 over 6 means 1 over 2. Why 3? Because 3 non-prime number. And getting this prime number, so there are 3 prime numbers, so 3 over 6 means 1 over 2. Okay. And yes, let's check here, is it correct? Yes, 1 plus 2 plus 1 plus 2 equals to 1. Okay, so probability distribution is correct. So I think you would have understood what is a discrete random variable by these two examples. So there are few points which you must know when you are doing this discrete random variable and its probability distribution. One new term you will learn here, that is expected value. Okay, ex. Ex. Yes, let's do here. Okay, expected value of x. So expected value of x is x times p. Okay, x time. It means 0 times 1 over 2, and this is 1 times 1 half. Okay, so you multiply, this will be 0 and this will be 1 half or 0.5 or 0.5. Okay, if I ask you what is the expected value ex of this distribution, so it will be 0.5. Okay, similarly, if you have to find out expected value in this second random experiment, you will do same thing. There is one more point which I want to discuss with you. We know what is the probability distribution, how to make probability distribution table. Sometimes you may have cumulative probability distribution table, and like this is a question number 4 from your exercise 13A. So here we need to find probability distribution from this cumulative probability distribution, right? So it's almost similar thing like you used to do with the frequency, and then how to find out cumulative frequency from the frequency. Okay, so here this is the table. Random C is the random variable, discrete random variable, I mean. So 1, 2, 3, 4, 5. Okay, this is, and here it's also the first value in cumulative probability and probability will be same, that is 0.07. But second onward will start to change. Second will be 0.09 minus 0.07, 0.02. Then third 0.26 minus 0.09. I think it should be 0.17. And then 0.72 minus 0.26. 12 minus 6 is 6. Okay, this will be 0.46. And then it will be 1 minus 0.2. So 28 means 0.28. It will be 0.28. Right? So this way you will find out the probability distribution from the cumulative probability distribution.